Hello, Sumit Kumar. Welcome to YourPedia. Let's start your snap interview for the subject control systems for your DRDO entry. What is a stable system?
So, stable system means we give input and sir, actually stable system that is that which follows BIBO stability, bounded input and bounded output stability, or asymptotic stability, sir. On which we control the output in desired manner, sir, not in uncontrolled way.
Okay, fine. So how to find, what are the methods to find system stability?
What, sir?
What are the methods to find system stability?
Sir, there are several methods for stability finding, sir. Routh-Hurwitz criteria, Nyquist criteria, root locus, border plot.
Okay. What are the disadvantages of Routh-Hurwitz criteria?
So Routh-Hurwitz criteria, sir, in Routh-Hurwitz criteria, when it becomes when the first column element becomes 0, then we proceed by letting him that x, which is
my question is what are the disadvantages of RH criteria, not the difficulties in RH? Means though we have RH criteria, we are going for Bode plot, polar plot, Nyquist plot and all. If for finding stability, if Routh-Hurwitz is enough, there is no need of going for other methods, right?
Sir, actually, Routh-Hurwitz criteria doesn't tell about relative stability. It gives absolute stability, sir.
What does it mean by relative stability?
So, relative stability is the stability that compares with other criteria, or we measure stability according to the parameters, sir, in that.
Okay, let's take two transfer functions. Transfer function 1 is equal to 1 by s plus 1. Transfer function 2 is equal to 1 by s plus 100. Among these two transfer functions, which one is more stable?
1 minute, sir. What you told, sir?
Transfer function 1 is 1 by s plus 1.
Okay.
Transfer function 2 is 1 by s plus 100.
Sir, s plus 1 minus 1. So s plus 1 by s plus 100 is more stable, sir.
How you are able to say that 1 by s plus 100 is more stable?
Sir, actually, the pole location of 1 by s plus 100 is far away from j omega axis than 1 by s plus 1.
So you mean to say if pole is far away from j omega axis, it is more stable? Can you justify your statement?
Sir, actually, whenever our pole location is near about the j omega axis, then by adding simple 1 0, it will become unstable, sir.
By adding it 0?
Yes, sir.
By adding it 0?
No, sir. Yes, sir. By adding 0 or case shifting or case shifting, we shifts the plots over, sir.
So you mean to say addition of 0 will make system unstable?
Yes, sir. Sometimes.
Can you take one example and can you prove? Suppose if take one transfer function.
Yes, sir.
One by s into s plus 1 into s plus 2.
1 by, sir?
S into
s into
s plus 1 into
s plus 1 into
s plus 2.
S plus 2.
Add 1 0 at minus 10. Take the 1 0 at s plus 10. 0 as s plus 10 or 0 at minus 10. Now you tell me the transfer function with 0 is more stable or without 0 is more stable? Take it as k. Instead of 1, take it as k. K into s plus 10 by s into s plus 1 into s plus 2 is the new transfer function. Old one is k by S into S plus 1 into S plus 2. Open loop transfer function I given.
Okay, okay, sir. So then without zero is more stable, sir.
Without zero is more stable. How you are able to justify?
Sir, actually, whenever zero involves in if अगर सर लेफ्ट साइड में भी अगर जीरो इन्वॉल्व होगा सर तो फिर हमारा जो रूट लोकस है वो पॉइंट उस पे नहीं आता है सर हमारा.
Can you repeat? Can you repeat? Do one thing. Draw the root locus.
Root locus.
Draw the root locus for both and show me. Sumit, you are taking a lot of time for sketching root locus. It is just a rough sketch I need, not a complete sketch.
Sir, actually, zero comes at plus 10 point.
No. I given the transfer function S plus 10. Numerator is S plus 10. K into S plus 10 by S into S plus 1 into S plus 2. If it is S plus 10, the zero will be at minus 10 in the left half of S plane.
Okay, okay, sir. Then root locus. Okay.
See, very rough sketch you can draw.
Hello, sir. Good evening.
Sir, it is.
Sir, good evening. We'll start, sir. Let me complete the Sumit Kumar's interview.
Sir,
we'll start for you, sir.
सर ये 1.5 पे सर ब्रेक अवे करेगा सर अब फिर एक हमारा जो जाएगा वो जीरो की तरफ जाएगा.
Sumit, I do not need where the break point, what is centroid and all. Just a very rough sketch if you draw. Adding a zero in the left half of S plane will make the system more stable. Adding a zero in the left half of S plane will increase the stability. See, I'll tell you very simply. Previously, there are 3 poles. Then there are 3 asymptotes. Asymptotic angles are plus 60, minus 60, 180. Right?
Yes, sir.
So it means there are 2 poles which are tending towards right half of S plane. But if you add a zero to that in the left half of S plane, the number of asymptotes are 2 only. What are the asymptotic angles? Plus 90 and minus 90, right?
Yes, sir.
So is there any pole which is going to the right half of S plane? No. Just with asymptotes and asymptotes angles, you can decide, man. Need not to do anything. See, when we take in K by S into S plus 1 into S plus 2, there are 3 poles, 3 branches of root locus, no zeros. Number of asymptotes are 3. If there are 3 asymptotes, 3 branches, in those 3 branches, 2 branches are going towards right half of S plane with an angle of plus 60 and minus 60. 1 branch is going towards left half of S plane with an angle of 180. Right? If we add a zero the number of asymptotes got decreased. There are two asymptotes only. What is the angle of asymptotes formula? 2q plus 1 into 180 by n minus m, where n minus m is equal to 2. Q is varied from 0 to 1. Then plus 90 and minus 90. So you are going to have your root locus only in the left half of S-plane, plus 90 upside, minus 90 downside. Never any pole goes towards the right half of S-plane. So adding a 0 in the left half of S-plane will increase the stability.
Okay.
Right?
Sir.
So let me give you feedback, Sumit Kumar, for today. I'll take 2 more snaps for you. So I recommend you to prepare this concept of root locus. Why? Because with root locus, most of the conclusions we will get just like that, very simply. Okay. Sketching root locus, you need not to find breakpoint. See, if you want to decide the stability, asymptotes and centroid is enough.
Yes, sir.
Why? Because see, our root locus is going to follow asymptotes, right?
Yes, sir.
If asymptotes are going towards the right half of S-plane, definitely root locus also will go towards right half of S-plane, right?
Sir.
Fine. So apart from that, yes, for all remaining questions, you answered very well. There is no issue. So the disadvantage of RH criteria, only one you given, that is it can't give relative stability. There are few more. For higher order systems, going with RH criteria is very difficult.
Okay.
See, up to 7th order, okay. But it is 100, S power 100. Then going with RH tabulation is damn difficult, right?
Yes, sir.
And one more difficulty is, suppose if your transfer function is having exponential powers, e power minus 2s. Suppose I give an open loop transfer function is equal to some k into e power minus 2s by s plus 1 is equal to 0, s plus 1. If you get the characteristic equation, you are going to get s plus 1 plus k into e power minus 2s is equal to 0. That expansion is infinite series, e power minus 2s, right?
Yes, sir.
Finding its stability is also going to be damn difficult. Okay. And relative stability. See, a system is said to be more stable when compared to other if its pole is far away from j omega axis when compared to other, right? Why? Because simply I'll tell you, if the pole is very near to origin, even a small disturbance can make that branch of root locus to enter into right half of S-plane.
Yes, sir.
So that way we can understand relative stability. See, I recommend you to go through this stability, root locus, and this frequency response part and come tomorrow. Fine?
Okay, sir.